Saxon Algebra 1/2, lesson 112. We are not going to talk about business math anymore. We're going to talk about probability. Probability is a math topic that falls within the category of statistics. Probability is based on, okay, here's the fancy definition. It's the study of outcomes that have an equal chance of occurring. It's mostly what we call game theory. It's what people study in gambling, to be honest with you, to find out what the odds are of different things. But we're going to use some harmless games. But that's what these probability problems are, is they're all about fun little games like spinners and rolling dice and flipping coins. So they're kind of fun. Plus, there's artwork, so that's always a plus. Okay, so the first thing I want to talk about is flipping coins. If you have any basic coin and you flip it, it's a perfectly even chance that it's going to land heads or tails, right? Those are the two different outcomes, and one is not more likely than the other. Sometimes people will make fake coins, and they're weighted to fall more on heads or more on tails. But that's kind of an exception to the rule. So if you want to calculate the probability that you will, a second, I don't want to do it like that. I want to do it like this. If you want to calculate the probability that you'll get heads, this is shorthand for, it's not just a hashtag, it stands for number. Here's how you figure out the probability of something. We express it as a fraction. On the top is the number of desired outcomes. If we're flipping a coin, the only outcome we want is heads. Then you have to figure out how many are total outcomes. Well, if you flip a coin, you're either going to get heads or tails, so there's only two. So the probability of flipping a coin and getting it to come up heads is 1 out of 2. That's the basic idea. This is the formula that we can use to calculate any probability. Okay, let's say that we're rolling a die. Dice is 2, die is 1. That's confusing. It's a weird word. These are the 6 different possibilities that we can roll. You can get a 1. You can get a 2. You can get a 3. You can get, this is a game that only has 1 die. A lot of games have 2, but this is the kind when you only have 1. And 6s, boxcars, right? Okay, so what if we want to say, what's the probability of rolling the die, and getting a number that's greater than 4? Okay, how many desired outcomes does that leave us? Okay, that just means 5 or 6, right? So there's 2 desired outcomes, and then what are the total outcomes? Well, there's 6 different sides to the die representing a different number, so it's 2 out of 6. When we're calculating probabilities, we reduce our fractions. So we would say that the probability of rolling greater than 4 with a single die is 1 out of 3. Those weren't even the real examples. A deck of cards. Okay, let me just remind you of how cards works. Cards, there are 52 cards in all. I don't know how familiar you are. I don't know how familiar you are with playing cards, so I'm going to briefly review what a deck of cards looks like. There are 52 cards in a deck. There are 4 suits, we call them, right? There's hearts, there's diamonds, There's spades, which is an upside down heart with a stem. And there's clubs, which is like a paw print with a thing, right? 4 suits, and they have 13 cards each. And I don't know that we need to know this in this lesson, but these two are red suits. These two are black suits. And then we know, oh, black, BL. So there's 13 cards in each, and it goes aces, kind of act like the ones, and then it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it switches over to the people, right? Jack, queen, king. So those are the 13 cards in each suit. So there's like a 6 of hearts and an 8 of clubs. There's 4 of each one of these in the deck. Okay, flipping. Now that's on the other page and we just have to remember it. We can't look at it. Okay, so here's our situation. Jimmy's got a deck of cards. He tears up the ace of spades. Sounds like Jimmy's a sore loser. But that's okay. We all have our moments. Jimmy tears up the ace of spades. Then he shuffles the remainder of the deck and draws 1 card. What is the probability that the card is a spade? Okay, let's write out what didn't happen. If he didn't tear it up, then I'm going to rewrite our formula. And this is the shorthand way I remember it. The number of desired outcomes over the number of total outcomes. I don't write outcomes each time. If he didn't tear it up, then there would be 13 spades out of 52 cards, right? Because we said there were 13 of each suit. And there's 52 in all. Okay, but here's the problem. He ripped up the ace of spades. So that means, but he did tear it up. So that means there's only 12 spades out of 51 cards, right? Because one of the spades is missing, and so now we don't have 52 in the deck either. So 12 out of 51, and this actually reduces because 3 goes into both numbers. 3 goes into this 4 times, and 3 goes into this 17 times. So after Jimmy tears up that ace of spades, the odds of pulling a spade out of the remaining deck is 4 out of 17. Cool, right? Okay, one more, and then we're done. This one is interesting. It's not hard, but there's a little bit of a trick to it. One die is red and the other die is green. Both are rolled. What is the probability of getting a 7 or a 4? Okay, last time we drew out the picture of the different outcomes if you're rolling one die. What if you're rolling 2 dice? Okay, we can make a chart to visualize all the different outcomes. 1, 2, 3, 4, 5, 6. This represents the red die. When we roll it, we can get any combination of those. But up here, I'm using the blue lines of the paper for the red die, but the green, I'm going to have to draw my own. But we also got a green die, and we're rolling that, so that could reach any of those outcomes. Just going to close up my box so it looks neat. You've played Monopoly before, I'm sure. You throw 2 die or a pair of dice in Monopoly, and so you'll recognize this as all the different outcomes that you could get, right? on one die and the other. So now what we're going to do is we're going to add them together, because that's what you do when you are playing the game, right? You add what you get. If you roll a 1 and a 1, then you get to move 2 jumps, right? If you roll a 1 and a 2, you get to move 3. You add them, right? So we're going to quickly just fill in this chart with what your actual move would be if this is what the 2 dice said. And it goes really fast because we're just adding 1 to each number. 3 and 1 starts with 4, and then we go up. 4 and 1 starts with 5. And I'm just double checking to make sure. 6 and 4, yeah, I'd move a 10. 5 and 1 is 6. And then 6 and 1. Okay, so here's what our dice would say. Here's the move we would get to make. Now, what's the probability of getting a sum of 7? So in other words, our actual move is 7. Grace, what is it? Grace is barking. She was sleeping quietly on the couch, and now she's in red alert mode. Good girl, girl. Good girl, girl? Well, whatever. Okay, so here are all the 7s. That's the desired outcome, right? 1, 2, 3, 4, 5, 6 rolls give us a move of 7. How many rolls are there in all? How many different combinations? Well, I could count all these up, but I can also go, oh, well, it's 6 times 6. There's 36 possible outcomes when you roll a pair of dice. That's a lot, isn't it? And so the probability of rolling a 7 is actually just 1 out of 6. Does that make sense? Once you figure out that this table is how you find all of your outcomes, then these problems are greatly simplified. What's the probability of getting a 4? Not a 4 showing up on one of the dice, but your total move being a 4. The sum of 4 is the way that John says it. A sum of 4. Okay. 1, 2, 3. There's only 3 rolls that get you a 4. And we know there's 36 rolls in all, right? 6 times 6. So the probability of rolling a move of 4 is 1 out of 9. Reduce if you can. Wait. Here's what I did wrong. 1, 2, 3. Not 4. I confused myself. There are only 3 ways to get a 4, so there's the 3. So this becomes 1 out of 12. My bad. Make sense? Now that I've confused you right at the end, right? But no, I was just writing down a 4 because that's the roll we were talking about, but there are only 3 ways to get a 4. So that's the right answer. Yay! Okay, lesson 112 is done. We're getting there, Caleb. Enjoy your weekend.